retaining walls. But before starting, anybody has any idea about what is the meaning of retaining wall? Why we are using retaining walls? Any idea? Why? Why we are using retaining wall? What is the meaning of a retaining wall? For what? Lose ground. Okay. Okay. It's a good point. Thank you, Brian. Yes. Retaining wall is a structure that holds back soil from a building or structure. Can you watch for this wall? This one is a wall. And this one called retaining wall. It supports a soil behind this wall. Can you watch this vehicle or this car on the ground? So we have a ground surface difference. The surface of the ground in this area at this level, the surface of the ground for this area at this level. So we have a difference between this level and this level. If you didn't construct retaining wall, we expect collapse, or you have to make the soil like this. You have to make soil like slope. But here we did vertical cut like this. We cannot do this without something here to support the soil. Retaining wall is a critical structure. Sometimes we expect collapse. Let's start to watch some of these videos to understand what is the meaning of a retaining wall. I will start with this video. This is a collapse in a retaining wall. Guys, we have a retaining wall supporting the soil behind. For what? This retaining wall or this retaining structure to help us to excavate this site for foundation. We are constructing a new building, so we did a very deep excavation. So we have a difference between this level of soil and this level of soil. So we construct this retaining structure to support the soil behind. For some reason, we have a collapse. Can you watch?
Osman, arkadaşlar hepiniz sağdan gelin yukarıya. Gelin yukarıya hepiniz. Mustafa, malzemeyi al gel yukarıya. Al gel yukarıya. Alın gelin yukarıya. Gelin çok geliyor hadi.
It looks like what? Guys, it looks like what? Yeah, I know it's a collapse. What is the reason for this collapse? I mean, if you have retaining wall and you have soil supported by this retaining wall, I expect lateral force. I will go back to the video and see what happened at the collapse moment exactly. Can you watch it again? One more time, please pay attention. What happened exactly? Horizontal movement. Can you watch? So I expect, no, not enough reinforcements because this is not a concrete structure, it's a wood. We have a pressure, yes, we have lateral pressure. We have a lateral pressure from soil. This structure is not concrete structure. It's a wood structure. The problem not with the reinforcement, the problem with something different. We have pushing from the soil. We have pushing from the soil. So if you have a retaining wall, the load on this wall will coming from this soil. The soil will push this wall horizontally. Let's see another video. This one is reinforced concrete. We have a huge height of soil.
Kameraya çek yukarıya. Sen al şu makineye sen çık istiyorsan ben alıyorum. Bırak şu makineyi yere atsana bırak. Biraz değil.
Hey guys, can you watch? Can you watch the building above? Can you watch the building here? It's a disaster. It's a big problem because collapse of a retaining wall will cause collapse in the soil. And this soil probably supporting another building. So it's not good to expect this kind of failure. Also, if you go back to the video, we expect lateral movement. All of these steel beams trying to support this wall laterally. So we have a big issue with the lateral movement of the retaining wall. And this lateral movement coming from the lateral pressure from the soil. One more time. Yes, I believe Oliver, yes. Can you I will show you a person here.
Ya git abla git ya. Şunun makinesini al. Kameraya çek.
Hey guys, can you watch this person? I believe he is an engineer. He is responsible for this collapse. So he is putting his hand on his head because he is expecting what will happen for him. Okay? So be careful. You are, as a designer, you are responsible for any collapse. Yes. So I hope for everybody not to be in this situation. It's a bad situation. Anyway, one more. Let's see one more. I think the third one is a collapse also.
This is an example of a retaining wall failure.
Yeah. Can you expect what will happen? Here is the retaining wall. It's an experiment. And here is the soil. This retaining wall supporting this soil. This retaining wall supporting this soil. This soil is trying to push this retaining wall.
A familiar hazard in ground engineering.
Any horizontal movement for any reason, sliding, overturning, anything related to these two movements, sliding or overturning for the retaining wall, failure will happen for the soil.
Find a wall to hold the dry, sandy soil whilst houses have been built above. Examples of this can be seen where roads or railways or other excavations have been built that cut into the land. Unfortunately, this wall has not been designed correctly and has started to fail.
I think this failure is overturning the retaining wall, trying to overturn around this edge. Will cause collapse for the soil and collapse for anything on this soil.
This slope failure is translational in nature, and you can see the slip planes that have formed. Slope failures in wet clays and silts tend to fail at shallow angles and be of a rotational or flow type failure.
Any question? So you have to calculate the lateral pressure from the soil correctly. And you have to check the stability of the retaining wall against sliding and against overturning. Okay? That makes sense? This topic is related mainly to soil mechanics, but I will cover it a little bit in our course because it's talking about soil and properties of soil. Anyway, we have different types of retaining wall. Sometimes the retaining wall can be called gravity retaining wall. We have a massive structure like this one. Massive means huge amount of concrete, because the huge amount of concrete will have a huge weight. This weight will make will cause support or will support this retaining wall against the lateral pressure from the soil. So we don't need any reinforcement, just concrete, plain concrete without reinforcement, but huge amount, large dimensions of concrete to make support to the soil. But before continue, guys, I need to make sure you understand what's going on. We have a level of soil. We have another level of soil. We need to construct something in between to support this high level from collapse due to the difference in the levels. Because one of you will say, hey, we have a soil level like this, ground surface, and I will construct a retaining wall like this. Are you kidding me? What is the main purpose for this one? What is that? Nothing. To construct a retaining wall, we must have a difference between a two level. And that makes sense. Okay. The second type of retaining wall called cantilever retaining wall, it's reinforced concrete. This one is a reinforced concrete. We have concrete and reinforcement supporting this soil behind this retaining wall. So the first type called gravity retaining wall, just massive mass of concrete. The second one, cantilever retaining wall. No, we are using small dimensions of concrete, but with reinforcement. The third type called sheet pile. We have steel shapes like this, and this shapes has a specific or special shape, so we can construct this one and this one by driven. Let's watch this video and see how the retaining wall is constructed. Interesting. So guys, the sheet pile is a sheet, steel sheet, as you see on the ground, this one. So we have a technique by raising this sheet pile and putting in the position and try to drive it to the soil. Make sure you are paying attention because you should ask me a question right now. So guys, to make sure you are constructing this sheet pile correctly, at the edge of each sheet, we have a connection. One of them is male and the other one is female. So he is trying to adjust the connection before sliding this one down. He is doing some vibration. This vibration will help to drive this pile or this sheet pile to the soil. The other guy is trying to adjust this pile to be in a vertical position. He has a water level, so he's trying to adjust this one to be in a vertical position. So, what is your question for this video? Guys, do you have any question for this video? You should ask me a question. It's a good question. Can you watch this photo and this video? How much? Yeah, it's the depths. It's not a big deal. It's not an issue. It depends on your design. I will let you know based on your design for the sheet pile. But you should ask me another question. Someone will watch this video and say, hey, you just told us to construct a retaining wall or sheeting pile or something. You should have a difference between this level of soil and this level of soil. Doesn't make any sense to use a sheet pile or a retaining wall for a ground surface with the two levels are equal. If you watch this video, hey, we are driving these piles or these sheet piles, and the soil level here is the same like here. So what's going on? Does that make sense? This question should make sense for you. That's right. They are planning to excavate one side. Before starting to excavate, the ground surface is the same. And then they drive these sheet piles in the ground like this. Once they are done, they will start to excavate the site. Excavation. I cannot start to excavate first before construct these sheet piles. That makes sense? So for the case of sheet piles, we are constructing them first. And the ground surface is the same. Once we are done around the area of the land, then we will start to excavate the site for a certain depth. Then this retaining wall or these sheet piles are there. So the final shape will be like this. The final ground surface after excavation at this level, and the original ground surface at this level. This retaining wall or these sheet piles supporting this soil from collapse. Okay. Okay. Sometimes, guys, I think that makes sense for you. If you have this level of soil and this level of soil, I think the retaining wall or the sheet pile must be driven to another depth here, and that makes sense. Why? Because this depth will make fixation for the sheet pile or the retaining wall from overturning. That makes sense? It doesn't make any sense to have this surface or this ground level and this ground level and to construct the retaining wall like this. Doesn't make any sense. I believe this soil will push this retaining wall and move it. We should have a driven depth here to make fixation for the sheet pile. Do you agree? Do you agree? Sometimes we don't have this option. Why? Because this depth is too long, too deep. If you add to this length another depth for fixation, you expect 100 feet or 80 feet, very, 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 very deep. We have another option which called anchored retaining wall. What you mean by anchored? Okay, I can give you another option. Here is a retaining wall. Here is the soil supported. Here is the other side of soil. I will put anchor here. This anchor supported by this soil and supporting this wall. I will put another anchor. I will put another anchor. This is called anchored retaining wall. Here is the retaining wall. I don't have enough depth here, so I will anchor this retaining wall by this one. How can I construct this one? Can you watch this retaining wall? At this location, we have anchors. These anchors extending to the soil behind this retaining wall. Let's try to watch this video. This topic is very interesting. Can you see? We have a technique. After you construct the retaining wall, I will construct the anchor using this machine. This material called grout. Something looks like cement with water. I am done. I have another one. We have a vertical piles, concrete piles, and we already make this hole inside the soil. And we have a cable, and this cable will be pre-stressed. So this one is pre-stressed anchors. this one is called hydraulic jack. Is trying to pull these cables out to make pre-stressed. I will talk about this next week in more details. So by the way, this one is called pre-stressed anchors, but this anchor supporting this retaining wall inside the soil behind. So we have a chromium system. This retaining wall supporting the soil, at the same time the soil supporting this anchor to support this retaining wall. We have self-acrobium. Okay? Yes. Cable in pre-stressed. It's a dangerous hydraulic jack because if something wrong happen, we can expect deadly accident. Okay? So can you watch? When this jack trying to pull these cables out, this person should be far away a little bit from this anchors, from this hydraulic jack. It's very dangerous. Yeah, it's very dangerous. I visit a company for pre-stress before in Missouri. When they are pulling these cables, everybody should be sheltered during this process. They cannot start to make this process if anybody around this area. Okay, and I believe we have these companies here in Texas, but no way to visit them at this time for COVID-19. Anyway, let's go back. So we have different type of retaining wall: gravity retaining wall, cantilevered retaining wall, sheet pile, anchored retaining wall, and these anchors probably sometimes they are pre-stressed. Okay, so we agreed that the effect of the soil on the retaining wall is lateral pressure. This lateral pressure can be divided between active and passive. One side will be active, lateral pressure. The other side will be passive, lateral pressure. And you have to decide which side is active and which side is passive. It's very easy. What do you expect for this retaining wall? What do you expect the movement? Do you think this retaining wall will be moved to right or will be moved to left under the effect of this soil and this soil? What is your expectation? I need answer. Guys, one more time. We have a soil at this level. We have another soil at this level. We have a retaining wall in between. Which soil will push this retaining wall? Do you think this soil will push this retaining wall to left? Or this soil will push this retaining wall to right? What is your expectation? I think that makes sense. This soil has a higher level than this level. So I expect this soil will try to push this retaining wall away. So this soil can be called or can cause active lateral pressure. and the retaining wall is coming in this soil, so this one can be called passive retaining wall. So before starting to solve any retaining wall, you have to decide which side of soil is active and which one is passive. Which one is active? With the higher ground surface. Which one is passive? With the lower ground surface. We discussed this before. We discussed that we should have a difference between this level and this level, because one of you will ask me, hey, if both of them at the same level, doesn't make any sense. Doesn't make any sense. This side and this side at the same level. No way. We should have a difference in levels. So with the higher level will be active. With the lower level will be passive. It's very important to understand this point. So guys, lateral earth pressure can be divided between active and passive. Can be divided between active and passive earth pressure. Any questions so far? Yes. Yes, Brock. Any questions so far? Okay. I will start first if we are talking about water. And we discussed this phenomena in hydraulics. If you have water surface and you are talking about this point, pressure at any point in water equal gamma H. Gamma for water, H the height of water above this point. Do you remember that? And this pressure is the same value horizontally or vertically or any direction. So the pressure in this direction is the same like pressure in this direction is the same like pressure in this direction is the same like pressure in this direction, because you are talking about water. Because you are talking about water. So pressure from water equal gamma H. Gamma for water, H for soil. I'm sorry, for water. The distance between the point and the water level, the water surface. This is the case if you are talking about water. Okay. But if we have a soil, the same sequence. Pressure for the soil equal gamma H. But at this moment, gamma soil and H soil. But I think the lateral pressure from soil not looks like the lateral pressure from water. I think there is a big difference. So we have another factor here called K. This K, probably K active, probably K passive. How can I know this? That's a good question. If you are talking about this side of soil, this side will be active. Why? We have a higher level of soil. That means this pressure will be K active gamma H. H is the distance between this point and the soil surface. But at this point, we don't have H, K active gamma H. We don't have H, so the pressure is 0. We have a value here, so we have a triangle. That makes sense. On the other side, we have lower level of soil. So we have passive. So the pressure at this location will be K passive gamma H. Gamma soil, H soil. At this point, we don't have H. K active, K passive, gamma H. We don't have H. So the value is 0. So we will have triangle. So the only difference between this side and this side is this factor. This factor will be active or sometimes will be passive. How can I figure out the value of this factor? K active equal 1 minus sine phi divide 1 plus sine phi according to soil mechanics. K passive will be 1 plus sine phi and divide 1 minus sine phi or equal 1 divide K active. What is the meaning of phi? It's a soil property. Angle of internal friction of the soil. Sand has higher value of phi, around 30. Gravel has a higher value of phi, around 34 or 35. Clay, probably phi equals 0. We don't have internal friction between particles. So the internal friction of soil is called phi. This phi will help you to figure out the value of K active and the value of K passive. Once you figured out the value of K active and the K passive, you can figure out the lateral pressure. Once you figured out the lateral pressure, I can figure out the lateral force in this side and this side. And see if this one is greater than this one, we need support for this retaining wall, or we can check overturning, we can check sliding, we can do everything. All collapse that you watched, the engineer or the designer miscalculate these lateral pressure. Not he didn't or she didn't calculate these lateral pressure accurately. So guys, pressure, lateral pressure for soil is gamma H time a factor. This factor called K. Sometimes this factor is K active, sometimes it's K passive, depend on which side you are talking about. If you decide it's a K active, okay, K active equal 1 minus sine, divide 1 plus sine. Sine what? Phi. Phi is angle of internal friction. So what type of soil here? Once you decide what type of soil, I can decide what is the value of phi. Once you get the value of K active and the K passive, I can construct this triangle. I can construct this triangle and figure out the total force and figure out the total force. Any question? Any question? So I covered today just a few points. What is the meaning of retaining wall? What are the types, the main types of retaining wall? What is the type of lateral soil pressure? Sometimes we have active, sometimes we have passive. Which side is active, which side is passive? I can figure it out. Okay. For water, we have for any liquid, pressure equal gamma H without anything else. But you are talking about soil, pressure equal gamma H time a factor K. This factor can be active or can be passive based on which side you are talking about. If you are talking about active side, so K active equal 1 minus sine divide 1 plus sine. If you are talking about passive side, so K passive equal 1 plus divide 1 minus or equal 1 divide K active. Sine what? Sine phi, and this phi called angle of internal friction.